Welcome everybody to this installment of In Conversation With. Today we are honored to have Bryan Berger. He's with the Department of Chemical Engineering with the University of Virginia. Welcome, Bryan.
Yeah, well, thanks for having me, and yeah, nice to see you again.
It's very nice to see you again. You are one of the people I met in the beginning of my hemp journey, many moons ago, and been so excited to watch everything that you've been doing with hemp over the years, and super excited to hear like what you're doing now and what you might have planned for the future. I know that a paper just came out in April, hemp cryo-milling and the impact of alkaline pretreatment on biochemical conversion. And I'm like, that sounds super exciting. And if I'm honest, I have absolutely no idea what that means.
Well, I'm glad you're excited because I'm excited about it too. Happy to tell you more about it. Yeah, I'm excited about it too because like we were chatting about all the and similarly like much of the beginnings of my hemp journey was kind of when I met you and others as well. So it's kind of fun that we're all reconnecting and sharing the fun things we've been getting up to with hemp. Yeah, this project I'm excited about because I think I'm excited about hemp for many reasons, but in this particular case, what I find really interesting is I'm a chemical engineer. I work in biotechnology. A big you've probably heard a lot about discussion about like the bioeconomy, powering the bioeconomy, decarbonization, finding alternatives to petrochemical inputs, ways of creating value-added materials and chemicals that don't depend on petrochemicals. And so I've long seen hemp as like a useful tool to achieve that. And so that's kind of in a nutshell what like one of the things I'm excited about in this paper was that it kind of took a nice team of industry, USDA, and university to kind of come together to figure out how it would work in this application. But yeah, really that's what this paper describes is kind of one specific application for hemp that I think will be really valuable in supporting this transition to a bioeconomy.
Okay, that's awesome. But explain to me, what does it mean? what is
Of course.
cryo milling?
Yep.
And what, give me the broad kind of layman's term version of what the paper researched and what your findings were.
Sure. Yeah. So, in this paper, what we were really interested in is, hemp has very high cellulose content in the fiber. That cellulose is a source of valuable sugars, and those sugars can be really valuable as feedstocks to drive fermentation. And so in the bioeconomy, fermentation is kind of king. You're using some sort of fermentation process because you have some engineered microbial system that's going to make some value-added product. But no matter what microbe and product you're making, you need that feedstock, that sugar source to feed the organism to grow. And so there's a lot like, when you hear about like biomass to biofuels or lignocellulosic conversion, this is kind of a similar idea, but hemp has a lot more valuable properties. It can grow much faster. It has regenerative capacity for soil. So using it can be really a valuable way to generate biomass that could then be converted into those sugars to drive fermentation. So that, at a high level, that's what this paper talks about is if you were to grow hemp and grow fiber varieties, and you wanted to take that fiber rich biomass and then figure out how to process it to turn it into a fermentation media to drive a fermentation process. That's kind of what we've described in this paper. So I think I'm excited about that. And then, on top of that, what I'm excited about is how effective the conversion is, and kind of in parallel, how much product we could make using the byproducts of that process. So the hemp derived materials really enabled high yields of products to be made. So it could be a really valuable feedstock in this case for fuel production.
Fuel production. Okay, so that's sort of what I was like. So, like what, like just like biofuel or like ethanol, or what types of fuels?
Yeah, so in this case, this is where my colleagues at the USDA uh, have a lot more of the expertise in this. They've engineered yeast to make an intermediate. It's 2,3-BDO. So this is a chemical intermediate that can then be upgraded into fuels. And so there's a variety of different types of products that could be made from it. So really what we did was make this key intermediate that once you have this intermediate, you can, remove a petrochemical input, put this bio input in, and then from there go on to make your various fuels or other products you want to make.
And then would that be seamless with like existing processes for making fuels already? Like it would just literally be using hemp as the feedstock instead of something else?
Yeah, I think a lot of what they're doing at USDA is looking at these bio-based, fermentation processes, so that a lot of the expertise in terms of the fermentation process, the outcomes of that fermentation, like the products and how that plugs into the fuel supply, is really their expertise. Yeah, they've developed a lot of these things and have expertise in it. So yeah, I think hemp in that sense really isn't any different in terms of how it would plug in. It's just more valuable because we're getting more sugars out of that process and therefore greater yields coming out of the fermentation using hemp. So hemp is kind of a more valuable way to make more fuel in this case.
That's
If that
awesome.
makes sense.
Yeah, well, and I guess the sheer amount of biomass in addition to the sugars and whatever would make it pretty effective in that sense. So
Yeah.
so in this case, I would assume would there be like no retting involved? It would be like literally mowing it down and baling it immediately to send it to whatever the facility would be, or is there any, is it like direct from farm to
Right.
facility?
That's another good question. I'm glad you asked that because that's kind of where the air products industry part comes in. And then some of the other ideas was that, yeah, we wanted to look at this is a big challenge in general with fermentation. When you're using agricultural waste like corn stover, um, sugarcane or beet bagasse, these are sort of like agricultural residues that are converted into fermentation media. We're kind of doing a similar thing with hemp. There's a lot of feedstock variability. So, two different farmers grow under two different conditions. Maybe one rets it, one doesn't. So how much difference are you going to get in output after that? That's a lot of what we looked at in this paper too. Here we looked at, we really wanted to make it as simple as possible from a grower standpoint. So just taking that hemp straight out the field, processing it, and then minimizing the number of steps on farm that would be necessary for conversion. So we really kind of stuck to that part of it. Doesn't mean that you couldn't do these other types of feedstocks, but that was kind of the path we chose, if that makes sense.
Yeah, that does make sense. But to your point, so other feedstocks that are currently being used for biofuels are, I guess, in essence, otherwise waste. Would we be talking about purpose growing hemp? And will the extra value for that be make it profitable for farmers to grow it for that purpose when otherwise it would just be, the additional revenue of sending their waste to a fermentation facility?
Yeah, yeah, that's something we're hoping to explore. We've applied for some grants now, and we were just talking about other grants to apply for. That's one thing we want to look at is do a more detailed techno-economic analysis and figure out which of these would be most beneficial to the grower. In the paper itself, we actually took some kind of spent residue, like say if you did retting and decortication, you took the residual kind of waste material afterwards, you could take that waste material and up convert it into fermentable sugars. So one thought you might have is you're growing for fiber, you're harvesting that fiber, and then the waste from that process could then be put into this value stream to make fermentation media. So
I think it would
that's,
be really
yeah.
interesting too to look at grain production. Because
Mhm.
grain production has quite a bit of residual stalk material that's not really suitable for decortication. That might be a viable candidate for something like this as well. And
Yeah, would love to. Yeah, if you know folks or you think there are people who would be interested in working with us on that, that I think that would be great. I think that that's a lot of what we're hoping this paper will allow us to do is like kind of reconnect with folks like you who would read it and say, okay, here's a good idea. You really should try this next, so we can try to figure out how to make it economically viable.
I think in a way, I think we were talking a little bit offline too about the possibility of using hemp for remediation for soil health
Hmm.
purposes and extracting toxins and heavy metals or whatnot from soil, and then seeing if it would still be safe and usable for some application like this. Because then all of a sudden you'd be looking at a scenario where you're not just like reclaiming
Yep.
marginalized or contaminated land, that you would actually be able to pull some revenue from that land as well, which I think would be a pretty fantastic thing to discover.
I I agree completely. Like we that's definitely we published a different study this year. It was with a different group where we were doing phytoremediation using hemp. This was looking at forever chemicals and removing those from soil and kind of characterizing the uptake into hemp. But that with
Work.
an eye towards, yeah, yeah. I mean, it works pretty well. I think that study was a lot more geared towards understanding what are the plant characteristics most favorable for sequestration from soil. To kind of figure out what types of hemp cultivars would work best, what growth conditions would work best. So it was less about hemp versus other crops and more about figuring out how to cultivate hemp under best conditions to maximize recovery.
So
Um,
it's fair to say like hemp is a hyper accumulator of like literally everything. Like I, I've heard of it for heavy metals, like obviously forever, but you're saying like it soaks up forever chemicals too?
yeah, in our study it did. And we have some laboratory studies like in the greenhouse here that would support that as well. I think
Wow.
there's a lot of plants have all sorts of regulatory mechanisms in their root structures to facilitate transport into the plant, whether it's heavy metals or other types of toxins. But these forever chemicals can be mobile in water and soil, and therefore sort of passively taken up by the plant, as well as actively transported. So that's a lot of the research we just got a grant funded that's going to allow us to do some of this work over the next few years and try to understand that process better. So we're pretty excited about that too. So yeah, it's
Oh,
like
that sounds
yet
super
another,
exciting.
yeah, we should talk another time about that or when we're writing this grant, because I think this could be helpful too.
Yeah, because I've long
Um,
wondered, like, it's one thing to, I mean, I guess that's always been my question in using hemp as a hyper, accumulator remediation option for anything. Like, what do you do with the plant material once you have it? Because like lots of things
yep.
that you would think about doing with it are just going to release whatever it was that you're trying to soak up, like back into the environment in some way, shape, or form. So, you know, like how do you get rid of a forever chemical? Like even if it's in hemp,
I
like
know.
what do you do?
Yep. That's what a lot of what we're hoping these studies that we published this year are going to be the kind of the very like beginnings of is looking to see. Because yeah, like you mentioned, like heavy metals. I mean, here in Virginia, arsenic, there's other sort of metals that are at relatively high levels just naturally in soils in state. And for people that grow hemp, they're going to have those accumulate just naturally in the crops that they grow. So understanding how we can process that downstream is going to be very important. So I think this process we described might lend itself to actually doing kind of some remediation as well. Like in the fermentation process, you think about taking that biomass, feeding it to a microorganism. What if you're supplementing or processing it with a different microorganism that's then neutralizing or degrading that toxin before it gets fed to the fermentation process to make the product, or in combination? Once you have that fermentation process, you kind of have a lot of space to explore. to try and design a process that cleans it up and makes something. If you have a lot more control at that point, I guess.
Yeah, I guess that makes a whole lot of sense. So in the study that was just released, what does cryo milling mean?
Yeah, so this is really Air Products forte, and they're a world leader in this. So they've developed, a variety of technologies to cryogenically freeze materials, such as hemp, and then mill them. And so that cryo milling process, it's allows you to embrittle the fiber. And when you do that, you can break it down to a finer particle size. And that becomes very important when you want to then convert that material into something else, kind of post. So you take the fiber, you harvest it, you mill it, you convert it, and then you do fermentation on that converted product. So the milling kind of comes, at the beginning.
So they take like an entire bale of something and
Mhm.
freeze it and then chop it up, like so to speak.
Yeah, yeah. With them, we did kind of smaller. You'll see in the paper, like kind of laboratory scale testing and some, but yeah, it's a process that could be done at larger scale as well.
I guess that
Um,
would make it easier to transport the material to the ultimate fermentation place as well. If it would be a much more, I imagine, much more compact and stable. Does it also kind of stop? Like I imagine if you would bale hemp like just green, that it would start like not maybe fermenting, but like getting kind of nasty and also maybe be at risk of like combustion and stuff like that if you don't dry it properly first.
oh, you talk about like just mold or other types of like
Yeah.
contamination of it.
Or does it
Yeah,
not
so
matter?
for us, again, this is kind of with the idea of trying to make it as easy as possible, like minimal number of steps. If you harvest the wet fiber and you still have a lot of the water content present, that in the cryogenic freezing makes the material more brittle and therefore able to break down into smaller size more effectively. If you had dried material, I mean, you know how tough hemp fiber is. That's why people like to use it for a lot of different purposes. Yeah, it becomes very difficult to break down as a
Right.
result of that because that fiber is so tough. But if you have all that water present in the wet fiber, that makes it more brittle, and so that milling process allows you to break it down. And like you said, then it's easier to transport, it's easier to convert, much easier to handle
Is
afterwards.
Air Products
So
currently doing that with any other crops on the type of scale that you'd be looking at for hemp?
I would have to imagine they would. I mean, I'm sure if you were to go to their website and kind of read about what they're doing, they have a lot of different products and processes they work on. So yeah, I can't say off the top of my head, but I would have to guess yes.
That'd
So
be interesting. So getting something like that to scale wouldn't necessarily be that difficult if they're
I
already doing it for other crops.
no, I mean, I think there are commercial examples of it in use. And so, yeah, to achieve a commercial scale wouldn't be impossible. And we had done different types of studies with them using bales, individual fibers. So that's kind of the value of working with an industry partner like that is they have the expertise to really tell you if it's going to work or not at scale. So that
Right.
I think that makes that's another thing for us. If you think about making fuels or value added chemicals out of this, it really has to be achievable at a
Right.
large scale. So,
Definitely.
um, so having them and USDA is kind of helpful to prove this works.
Excellent. And then what about the alkaline pretreatment? What's that part of it mean?
Oh, so this gets to like the kind of the de-intensification of the process. So if you want to make a process green or kind of minimize the amount of like chemical treatments necessary. Um, you know, what we kind of showed is there's sort of a balance between the chemical pre-treatment, which is necessary to break the fiber down, recover the sugars and do the fermentation, and the impact of the cryo milling. So, by following this process that we described, um, it kind of de-intensifies the amount of chemical treatment necessary, which is another advantage. So you're using less of these kind of harsh chemicals in the
Oh, I see.
processing.
So you're saying that
It's kind of a trade-off.
you determined that the cryo milling, that process by itself reduces the amount of alkaline pretreatment that you would normally have to do.
Yep.
So
So
like
it
the
kind of went from
alkaline
like
pre
high to, yeah, moderate treatments with the sodium hydroxide or the alkaline pretreatment. That's kind of talked about in the paper as well.
and this paper, is it available to anybody to go and look at?
Yeah, yeah, it's up on the web. I think I don't I it looks like, I think because it's recently published, it's not open access yet. But
But
if you
we'll,
have a subscription to like American Chemical Society or you're at a university like us, you can have access to it. But
okay. Well, then I will put a link up in the description here for anybody who has access to those types of things and wants to take another look. Is there
sure.
anybody anywhere that like takes studies and makes them understandable for regular people? Like I did read the study and I'm like, what?
Yeah,
Which why I needed you to come and explain to me
right.
like what this is and what it means.
I don't, I mean, maybe depending on the nature of the study, if there's enough interest in it, someone, like a science communication type person might try to create a lot of the professional societies, even ACS has these types of things. For this paper specifically, I don't think so, no, but
Yeah, well, that's what
like,
kind of what I figured. I tried to put pieces of it into to chat, GPS and see what
oh,
AI did with it. And
yeah,
I'm like, I don't know if I trust this or not. So
right,
I
right.
think I'm gonna wait till I can talk to Brian and have him explain
Yeah,
it to
probably the
us.
best is to talk to us. But we're happy to talk with you anytime. So,
Well,
um,
that's super. I'm sure we're gonna have lots to talk about. Um, so tell me a little bit, what other studies you have done in hemp and what did get you interested in it in the first place?
oh, I mean, for me, I mean, the history was really interesting. I mean, we met back in Pennsylvania. I remember learning about some of the early Moravian settlers and some of the earliest sort of examples of hemp fiber processing occurring in Bethlehem. And so that was interesting to me, learning more about the history, just seeing how much use there was. I live in Virginia now and talking to farmers who remember cultivating it, selling it, kind of got me interested in learning more about it, why. Um, and then I think as I learned more, I kind of realized, yeah, this is a really valuable um, crop that could really be useful and is still as useful today as it was back then. And I think with the biotechnology interest, yeah, I saw it from that perspective too. The decarbonization aspect in particular. We depend so much on petrochemical inputs for fuel, chemicals, materials. Hemp seems to have a lot of really valuable properties that would allow us to achieve more decarbonization or removal of these petrochemical inputs. So yeah, that like
That's
as a scientist doing research in that area, I kind of saw, okay, hemp could be a really powerful tool to achieve this goal. So
So I think it seems super exciting to me that it's at least my impression is that as somebody who has started out interested in hemp and has done actual legitimate scientific research on it and you're still excited about it, seems like the science is there, and just needs to have people like you to continue to do the research to prove it out. But that like everything that we talked about, for me, like some of the things have turned into, there were a lot of myths in the industry about what hemp can and cannot do. But
mhm.
now it's seeming like you're like discovering a whole kind of range of things that we like never knew it could do. Um, and that there's even more promise
Yeah,
in some
I mean, I
ways than
think
we even thought.
yeah, I think that's where the research needs to be done. I mean, that's what's exciting for us with the Farm Bill passing and the ability to do this kind of research now. I think that's what's really important is that gives us the ability, like you say, to figure out, okay, hear all the uses for it, things we might not have even envisioned, but yeah, as an academic and a researcher, that's what we're really excited about, is having the ability to do this research to figure out, like, there's no doubt it'll be useful, just figuring out how and what it'll be useful for.
Yeah, that's
So,
great. And if the language that's in the current kind of draft of the Farm Bill stays in there, researchers like you will have a lot of reduced burdens on the actual hemp cultivation side in terms of not having to worry about if it goes hot, because it's not going to matter. As long as you're
right.
doing legitimate research on industrial hemp, which is, fiber grade or microgreens, um,
Yep.
you will benefit from not having to worry about things like the 30-day harvest window and the mandatory chemical testing and all that
Yeah.
kinds of stuff. That's kind of a hindrance to, getting the work done that needs to be done. So I'm kind of very excited that. So are you working on any hemp research right now, or anything on the horizon that you're excited about?
I think now that this paper is published, you were kind of excited to take this and push it forward. We're working now this summer with a group to kind of figure out you had mentioned earlier about the economics, trying to figure that out and see, I think this is very early stage research. We're not near a commercial product, but there's enough here for us to try to figure out, okay, if we were going to try to make this commercially viable and valuable to, incentivize growers to produce, what what products can we make that would enable it to be an economically viable process. So that's this grant that we just got most recently will allow us to begin to do that. We're really excited about that. Um, so I think for this project specifically, we're talking about that sort of the next steps, and then the other projects really looking more at use of hemp to remove or mitigate PFAS contamination, and how it could be used as a tool to help manage contamination on farm.
That's
So,
amazing.
yeah, I mean, I think it could be really valuable there too. And again, that's very much early stage. We work with a lot of um, plant biologists, growers, people that have much more agricultural expertise than I do.
Right.
But working with them will be interesting to see what could happen or how it could be valuable there.
So as an example, because I know, like, I hear frustration from people all the time, like, why aren't we doing this and why aren't we doing that? And it's like, guys, like, it's been legal for 5 years. I know that sounds like a long time, but like in the grand scheme of things, it's nothing. Like, they're still researching corn and soy. Okay, those things have been around for a very, very long time. Um, so from the time that you first, thought about doing this paper that just published in April, how long was that in the making, from thinking about it to applying for the grant to actually doing the research and getting the paper written? Like, what kind of time frame was that?
Oh, I mean, I think the paper itself, like the work, probably about a year. But I think you alluded to earlier that there just had been a lot of challenges to being able to do the work. Whether it was the testing of the plants, the permitting requirements, the land restrictions for use. So there are a lot of those types of challenges that kind of slowed things down. But once those became manageable, then and I think more recently, with some of the more recent farm bills being more supportive of hemp work, that's where industry, USDA, others started to take more of an interest. So I forget when it was, but they used to collect, I think USDA now collects data on acres of hemp grown. And so, once it became, I guess, a bit more normalized,
Yeah,
then it was a lot easier for us to do that. So that I feel like happened. COVID kind of screwed everything up. So there's also that like
that's
black
fair.
hole of COVID. I don't count, but
Yeah,
um,
definitely a black hole.
yeah,
So what do you think? Like 2 years, maybe?
yeah, I would say at least 2 years ago we had kind of. I mean, I think we've been excited about this for a long time. It's obvious that hemp that's high cellulosic content
Right,
and short grow time, low chemical inputs, high biomass density, just makes it so obvious as like an energy crop in
right.
my mind that I just had always been excited to do this, and then it just was the stars aligned a few years ago when I could find the group to work with to get us
That's amazing.
there.
Yeah,
Yeah.
energy's always been one of the things that I've been super excited about too. And then, and I heard all of the, all of the naysayers that were like, it'll never make economic sense. Like, first it was like, we'll never move away from petroleum products, right? That was the first thing. And then, now it's, I think, becoming obvious to pretty much everybody that we have to. And it's
Yeah.
not a question of whether we want to or whether we think it's economically viable or whatever. It's like, this needs to happen. And then it was like, well, hemp is going to be so much more valuable for other things, the textiles, the building materials, the grain products. And that might have some validity to it. So I'm really
Yeah.
interested in this economic work that you're about to doing. But when you start throwing in the possibility of doing this on otherwise unusable land for agriculture,
Right.
that's a different ball game altogether. Um,
Yep.
then, well, it is. It's a completely different ball game, and that it would definitely change things for the better. Because I've also heard some concerns, like with biofuels in general, not anything to do with hemp, that they're being concerned that if we start growing too many acres for
Yep.
biofuels, that we're taking away from food production.
Oh
Um,
yeah. That's a common argument, but I think, yeah, that people make when they're concerned about this. But that to me is like a reason why hemp is more potentially a solution, right? It doesn't need to be, it's not necessarily a food crop. It doesn't have to be grown on land where you cultivate food crops. And in fact, that's kind of an advantage hemp has, is that it can be grown in locations where you otherwise probably couldn't cultivate crops. So it doesn't
And you
compete
might even
necessarily.
eventually make that land able to support actual crops.
Potentially, yeah.
If you can remediate it over a 10-year period, like maybe the soil health will improve to the point where you could. We don't know that
Yeah.
yet, but
Yep.
worth looking
No,
into.
no, I think what you said is, I mean, I'm glad you brought that up because that to me is like something I often point out as an advantage of hemp is that it's not competing with land that we use for food crops. So you don't have that issue. So and that could potentially make it viable for fuel or chemical production. So that's to me, yeah, a principal advantage it has.
Yeah, I love it. I mean, especially the idea of taking like some of the old kind of like anthracite mine sites and places like that are just like barren moonscapes,
Yes.
and making them productive for something. Um,
Yep. Completely
it's
agree.
pretty amazing concept. Well, Brian, thank you so much for joining us today. Like this has been super exciting, and I can't wait to see what else that you get up to. And gonna try to pull you into some other projects that we're gonna try to get going.
Yeah. I look forward to working
Because
with you guys on that.
it's been a long journey. And
Yep.
it's really fulfilling to me to see, you and other people like actually doing what we always hope that you would be able to do, and that it is proving to be worth doing.
Yeah.
So
I mean, it kind of makes sense, right? There's a reason why we cultivated it for so long, for so many uses, and so it's kind of interesting. Yeah, there's an interesting history too, which I'm sure just about it. That is kind of, I think, interesting to bring back to people's attention again today too. So,
I agree. And I also think
yeah,
it's fair that the government do their fair share of helping to fund the type of research that has to happen, because we're 80, 90 years behind because of prohibition.
yeah,
So fair is fair.
yeah, agreed. Yeah,
All right. Well, again, thank you so much. We will please check in with us the next time
sure.
you have anything that you're, wanting to talk about. And we'll definitely be keeping tabs on you and your great work. So thank you again for being here.
Yeah, thanks for the opportunity. I look forward to staying in touch.
Awesome. And thank you everybody for watching this installment. We hope you enjoyed it, and we'll look forward to seeing you next time.